So when we talk base 10, here's what base 10 actually means. Everything in our math is based on the growth between the number 9 and the number 10. When we get to 9, we zero out our ones column and we put a 1 in our tens column. When we get to, say, 19, we zero out our ones column again and we start over with a 2 in our tens column, and then we say 20, 21, 22, 23, 24, 25, 26, all the way back up to 29, where we zero out our ones column again and start over again. This sounds like kindergarten simple, but a lot of times it's not the approach to thinking that we take in math. We just use the pieces and don't think about what they actually are. Well, when we get to 99, what we do in a base 10 is we get 10 times bigger than 10, because we are counting up our tens, and we get 10 times bigger. We say, zero out our ones, zero out our tens, and put a 1 in our hundreds. So we went, 10 is 10 times bigger than 1, 100 is 10 times bigger than 10, and it keeps bumping up. So when we do place values, what it actually is every time it gets 10 times bigger, we start a new place value and start counting over again. And when kids are little, and they're using manipulatives, this teeny tiny little thing is a 1. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9 of those until we get to this, which is a 10, which is 10 times bigger than this. And then we count up by our tens, 10, 20, 30, 40, 50, 60, 70, 80, 90, until we get to our hundreds, which is 10 tens. This is just a visual way to show younger kids what they're working with, rather than them just have to imagine a 9 or imagine a 27. Because younger kids can't, their brain just isn't there yet to physically picture something that matches the number they're working with. And when we get 10 times bigger than this, we get to 10. What this shows is exponential growth. Every time something gets 10 times bigger, it gets multiples. So that this and this compare in size and shape. The only difference is how many of them you need to put together. So when we talk base 10 math, in 5th grade, we're not counting up to thousands anymore. They've done that. They know their place values all the way up to like trillions and billions. So what we do, because it works by multiples of 10, is we take one of these and we say this is our 1. When we're teaching decimals and using how to manipulate decimals, we say this is 1/10 or 0.1 or 1 over 10, because this is 10 times smaller than this. And because it works by base 10, it doesn't really matter what fraction of 10 you use. This is the one we use because honestly it's easiest to draw. So when we're talking base 10 decimals, this is our 1, this is our 1/10, and this is our 1/100th. So that they can see physically splitting 10 of these pieces. When you physically put them together in a row, becomes one whole. So when I have 2/10 plus 3/10, I can put them together and get half of a whole. Or if I have 7/10 and I add 4/10 to it, what I actually get is 11/10 or 1 whole and 1/10 left over. And subtraction works the same way. If I know I need to split this up to subtract, if I have 11/10 and I want to subtract 4/10, well, it's not going to work like this. I can't just rip it apart. I need to look at that number and know that what I have to start with is 11 of these tenths, and then take away 4 to get this many left over, to get our 8/10 left over. No, sorry. Math teacher. To get our 7/10 left over. So when we're adding and subtracting in base 10 decimals, we use our manipulatives or drawings to physically give the kids something to picture. So what I just did, if we drew it, is 11/10 minus 4/10 will equal 7/10. And I teach the kids to do tally marks because it's an easier way. If there's only so many lines you can draw before you lose track. So if they show 5 lines by doing the tally mark 5 with the hashtag or the slash through the middle of it, it's just an easy way for them to look at that and go, oh, so when you're asking me to subtract all these numbers, it just means this, and they can picture it in their head as physical parts rather than just try to imagine what I'm talking about while they're learning the operations and taking notes and practicing it over and over again. If they can actually see the parts, for some kids, that's what actually jumps them up from, I'm just doing this to make my teacher be quiet, to I actually understand what I'm doing, I get through it pretty quick and not hate it. Because let's be honest, that's what math is known for. Lots of homework and kids not liking it. Well, that's not a good way to learn. If you hated your math class, chances are pretty high you didn't learn anything from your math class, or at least very little. So the next video I'm going to show how we do multiplying and dividing decimals rather than just adding and subtracting with our base 10.